the interstellar visitor, 3I Atlas, that and looked rather anomalous. The object is quite large, and it's also aligned in its path with a plane of the planets around the sun. So
Something massive and mysterious is racing through our solar system, and it isn't playing by our rules. It's bright, fast, oddly aligned, and forcing scientists to rethink what interstellar objects can be. If it's natural, it's unlike any comet we've studied. If it isn't, it may have been watching US for a very long time. Suspicious arrival. Right now, a 73 trillion pound object is tearing across the solar system at about 124,000 miles per hour, and it isn't local. Scientists detected extreme negative polarization in its light signature, something never seen in any comet before. Its path sits within 5 degrees of Earth's orbital plane, and it slid past Mars with timing so precise the chance of that alignment is less than 1 in a million. Harvard astrophysicist aviloeb estimates a 30 to 40% probability the object isn't entirely natural. During the recent US government shutdown, NASA's public data feeds went dark exactly as the object made its closest approach to Mars, sharpening suspicion at a critical moment. 3I/Atlas has already broken assumptions about interstellar visitors. It approached from a direction where extraterrestrial observers could watch Earth transit the Sun. Loeb calculates that any civilization within a 10-degree cone of our ecliptic could discover our system through transit surveys, just as we find exoplanets. Our planet's orbits, their timing, and which world hosts life would be knowable. The object's 5-degree alignment places it squarely in that detection zone. If someone sent this probe after observing Earth, they could have watched us for millennia, waiting for the right moment to arrive. For months, people have asked the same unsettling question: is 3I Atlas technological or natural? The answers are troubling because this visitor shows 7 documented anomalies that resist easy explanation. Unlike the cigar-shaped oumuamua or the typical comet Borisov, it refuses to fit any category. Mass, speed, trajectory. Start with its mass. At more than 73 trillion pounds, roughly 6 million times heavier than SpaceX's Starship, 3I Atlas barely reacts to its own outgassing. Normally, jets of gas push a comet around like a balloon letting out air. Here, visible outgassing creates a cloud, yet the trajectory hardly shifts, implying an enormous, remarkably stable mass. Based on the known density of material between stars, Loeb argues we should have seen hundreds of smaller interstellar objects before meeting one this big. We haven't. In his words, there isn't enough rocky material in interstellar space to explain such a giant rock arriving in the inner solar system now. The timing deepens the mystery. On October 3, 2025, 3I Atlas passed within 18 million miles of Mars, close enough for unprecedented images by orbiters and rovers. Perseverance recorded a slanted streak moving across the Martian sky that didn't match normal star trails. Yet, as this flyby occurred, NASA's websites and live data streams went quiet under the shutdown, choking off real-time information. What did reach the public is baffling. The object appears elongated, more like oumuamua than a round comet, and it lacks the dramatic tail expected from something so active. Instead, it's wrapped in a diffuse coma of ionized gas behaving unlike known cases. Its speed is also striking. Relative to Mars, it's racing at about 37 miles per second and will reach roughly 42 miles per second, near the Sun around 150,000 miles per hour, fast enough to circle Earth in about 10 minutes. Interstellar speeds aren't unusual, but combined with this mass, the kinetic energy is staggering. If 3I Atlas were engineered, it would represent technology far beyond anything we can build. The path looks deliberate. The object stays nearly flush with the ecliptic, the plane where planets orbit. The chance of that alignment happening randomly is about 1 in 500. It brushed close to Mars, will pass near Jupiter on March 16, 2026, and arrives at times that maximize encounters with multiple worlds. The odds of all these coincidences drop below 1 in a million. From an engineering standpoint, a mission designed to study several planets efficiently would do exactly this. Hug the ecliptic, time arrivals for planetary flybys, and use a shallow inclination for wide coverage. 3I Atlas will pass within about 33.5 million miles of Jupiter, close enough for detailed observations if any instruments are on board. As Loeb notes, a 5-degree inclination would be optimal for observing transits of main belt asteroids, which open about 10 degrees above and below the ecliptic. Light, dust, chemistry. Then there's the polarization anomaly. When sunlight scatters off comet dust, it produces a measurable pattern. Every comet we've studied shows positive polarization at large viewing angles. 3. IATLAS shows negative polarization about 2.7% at a phase angle of silence, 0.4 degrees more extreme than any comet on record. That means the dust around it is fundamentally different, perhaps rougher, more irregular, or made of unfamiliar materials. Its chemistry also stands out. Scientists detected cyanide and carbon monoxide, common in comets, but they also found signs that the environment around 3. IATLAS resembles Mars-like conditions, more than typical comet-forming regions. That hints the object may have come from a planetary surface, rather than the icy outskirts where comets are born. Near the Sun, it keeps defying predictions. On September 25, a coronal mass ejection struck it directly. Observers expected dramatic changes or even fragmentation. Follow-ups on September 27 and October 2 showed no breakup, no sudden tail, just a gradual expansion of its envelope. It appears more resilient than a natural comet should be. As size estimates improve, the nucleus keeps growing. Early guesses put it at a few hundred feet across. Now it appears roughly 3 miles wide, 3 miles of solid material, not counting the surrounding gas. For perspective, that's described as larger than the asteroid that killed the dinosaurs. Picture a small mountain flying so fast it could cross the United States in under 2 minutes. Combine that with the earlier mass estimate and near immunity to outgassing, and it drifts even farther from familiar comet physics. Visually, nothing about it is routine. It seems elongated, more like oumuamua's odd shape than a typical sphere. It lacks the bright structured tail we'd expect from sustained activity, yet it glows and changes in ways ordinary comets don't. Each measurement stretches what natural should look like. That's why scientists keep returning to the same phrase, a black swan. One impossibility might be a mistake. 7 anomalies begin to look like a pattern. Engineered or natural? If this object is artificial, the implications are unsettling. 3. IATLAS approached from a zone where distant observers could track Earth's transits. A probe sent from there would know our orbits, when to arrive, and how to thread a path past multiple planets. Its 5-degree orbital tilt would make sense for broad survey work. Its resilience to solar storms could point to advanced materials. And its near-ecliptic trajectory would be the logical way to harvest data across a whole system. Loeb frames the challenge simply. Those insisting on a purely natural origin must explain all 7 anomalies through natural processes. So far, no one has. The scientific community still leans toward a natural explanation because extraordinary claims need extraordinary evidence. But even cautious researchers are asking uncomfortable questions. The most haunting scenario borrows from strategy rather than astronomy, a Trojan horse. The perfect cover is to look almost like a comet, close enough to blend in, different enough that careful measurements whisper another story. Some scientists push an alternative that's wild in a different way. Dr. Suzanne Fine suggests massive interstellar objects like this can act as planetary seeds. In her simulations, such bodies plunging into young solar systems jumpstart planet formation. Instead of dust slowly clumping over millions of years, planets could grow rapidly around a ready-made core. If true, part of Jupiter's mass might trace back to an ancient interstellar visitor, much like this one. What happens next matters. European spacecraft kept watching while NASA's public feeds were down. ESA's Mars Express and the ExoMars trace. Gas Orbiter continued observations. The JUICE mission is slated to intercept 3, IATLAS in November 2025. Though data delays mean results won't be immediate, those views could reveal whether the surface has unusual features or whether the interior hides structures no natural object should possess. Perihelion arrives in late October. Some predict dramatic evaporation or fracture near its closest solar pass. Others expect it to shrug off the heat again. By December 19, 2025, it will sweep past at about 167 million miles from Earth. Our last good look before it fades back into interstellar space. After that, it becomes another secret lost to the dark between stars. Whether 3I Atlas proves natural or engineered, it has already redrawn the boundaries of what interstellar visitors can be. The mass seems too large, the composition too odd, the timing too perfect, the trajectory too precise. A decade ago, none of this sounded plausible. Now it is forcing us to design better surveys and be ready for the next surprise. If a civilization wanted to study solar systems quietly, hiding probes in plain sight as almost comets would be a clever tactic. And if planet formation can be kick-started by giant interstellar seeds, our own history may be stranger than we imagined. We are running out of time to study this one up close. The best we can do is gather every photon, test every hypothesis, and admit what we don't yet understand. The universe just revealed a new playbook. One that suggests our cosmic neighborhood may be busier, heavier, and more complex than we thought. Whatever 3I Atlas is, it has changed how we will look at the sky from now on. The next visitor might be even more unusual. This time we'll be ready. Thanks for watching. Don't forget to subscribe to Epoch Dive for more amazing documentaries.